There we go. So quadrilaterals. First of all, that prefix quad is sort of a clue as to what they are and what they're made of. So what does that prefix quad mean?
4.
4, yeah. So all a quadrilateral is a shape made up of 4 sides. Okay? So I'm going to start off, let's see, how should I do this? I'm going to kind of make like a family tree almost. So I'm going to start with quadrilaterals up at the top. So quadrilaterals are made up of 4-sided figures. I really should say, don't write figures. They're really 4-sided polygons. So what makes a polygon? A polygon is that it's just made up of straight edges. So we don't have any curves here. So like a heart shape or a circle, obviously those don't count as quadrilaterals or polygons at all, right? So polygons are just straight edges and they have to be closed. So like a W shape that doesn't come back and close wouldn't count as a polygon. All right, but that's pretty much all you need to have a quadrilateral. It just has to be 4 sides and it has to be a polygon. So those sides have to be straight and it has to close. All right, so I mean, there's lots of different ones. You could have, I mean, it could be as simple as a rectangle. It could be sort of like this funny shape, as long as those are straight edges. It could be, something like this. You have lots of different ones. As long as it has 4 sides and they're all straight sides, it counts. You could have like a diamond shape. You could have like a really weird, something like this. Any of those, okay? So quadrilaterals, very broad category. All I need are 4 straight sides that close. Okay, now branching off of that, if I happen to have a 4-sided polygon, so a quadrilateral, but it just so happens that the 2 pairs of opposite sides are parallel to each other, then we have our friend, the polygon. Parallelogram, sorry. Jeez Louise. Parallelogram. So, parallelogram, it has to be a quadrilateral. With both pairs of opposite sides parallel. So that's what's most important about a parallelogram. You have to have both of your opposite sides be parallel to each other. Okay, so you start off with a 4-sided figure, but if those opposite sides are parallel, so it's going to look something, could look like this, where you have the top and bottom parallel to each other, and then also the sides. So there's the parallelogram. A rectangle does fit this definition, doesn't it? Because the top and bottom would be parallel, and so would the sides. So rectangles count. A square would count too, wouldn't it? Because it still has 4 sides and top and bottom, and the sides are parallel. Even shaped like this. Okay, so as long as you have those both pairs of sides parallel to each other, and it has to be both. So actually, let's make a big deal about that. both pairs of opposite sides parallel. And that's all you need to create a parallelogram. As long as I have 4 sides and opposite sides are parallel, I have a parallelogram. Questions so far? No? All right. Old news, right? You guys have seen these before. So now we're going to branch off of parallelograms. And coming off of parallelograms, we're actually going to talk about 2 different types of parallelograms. Oh, which one should we do first? How about the rectangle, right? So the rectangle, what makes a rectangle a rectangle? Well, first of all, it is a type of parallelogram with, anybody know? What makes this different from this? What does this guy have that this one doesn't?
They're all straight. Like they don't, I don't know, like they're not.
Yeah, I get what you're talking about. It has to do with your angles. These are all slanty, right? But these are perfectly straight, like you say, because the angles in the corner here are all 90. That's what makes a rectangle. Okay, so it's a parallelogram to start off with, but then it also has 4 right angles. That's what's so special about it. So it's a type of parallelogram with 4 right angles. That's the big deal about a rectangle. Okay, so let's go ahead and draw a picture. So first you start off as a parallelogram, and then we're going to note that all my angles are right angles. So I do have both of those pairs of opposite sides parallel and 4 right angles. Cool. And of course, rectangles can look all sorts of different ways. One thing I want to caution you on in this section is that I know you know what a rectangle is, right? Like I know when you look at a rectangle, you can establish, yeah, yes, that's a rectangle. But sometimes kids get so confused with all the terminology that they start forgetting. So just go back. You know what a rectangle is. There's no doubt in my mind that you know. All right. Can you name another specific type of parallelogram for me besides a rectangle?
A square.
Yes. Give me another one besides a square. What's the name of the one where, okay, people sometimes erroneously call it a diamond shape. We're not going to use the term diamond shape. What do we really call it? It's a
rhombus?
Yes, a rhombus. A rhombus. All right, so also coming off of parallelogram, we have the rhombus. And what is so special about the rhombus is that it is another type of parallelogram, but what his claim to fame is that all 4 of his sides are the same length. So we don't really care about the angles, we care about the sides for the rhombus. The rectangle, we care about the angles, it has to have the 4 right angles. Rhombus, now I don't care about that. I just care that all 4 sides are the same. So a rhombus is a type of parallelogram with all 4 sides congruent. That's the big deal for a rhombus. Okay, so they could look a couple different ways. You could have kind of Oh, that's terrible. Hold on. I can do better. It's easier to draw them up and down, I think. Okay, and all four of these sides have to be congruent to each other. All right, so that's the big deal with the rhombus. Note that it is still a type of parallelogram, though. So it still has its opposite sides are still going to be parallel to each other. They're just, in addition, also going to be all the same length. Okay, now we all know our friend the square, and the square is basically just a rectangle and a rhombus put together. So if you take the qualities that a rectangle has and the rhombus and you put them together, you just create a square. That's all it is. So the square is going to still be a parallelogram, but it's going to have 4 right angles and 4 congruent sides. So let me get one more color here. And we're going to have the square that kind of comes back together and ties both of these in. Square. Can you see the green well enough? It's not great. Maybe I'll try, hold on, I've got this one too. Maybe this green comes up better. Yeah, I think so. Okay, square. So square, type of parallelogram. With both 4 right angles and 4 congruent sides. And of course, I know you know what a square looks like. All 4 sides the same and all 4 right angles. So that's pretty much it for the parallelogram branch. So we start off with, oh, sorry. I didn't realize that you wouldn't be able to see it all as well. So you start off with quadrilaterals as sort of the overarching umbrella of the whole thing. And then you get parallelograms sprout off of that. And then you have rectangle and rhombus that sprout off of the parallelograms. And then the square is the mix of the two. Now, we have 2 more different types of quadrilaterals that we're going to talk about that are not parallelograms. So I'm going to flip to the next page and talk about those. Hang on, I got something in the chat that I just want to make sure that I answer. Okay, so any questions on quadrilaterals, parallelograms, rectangles, rhombus, or squares? By the way, do you know what the plural of rhombus is? Anybody know the plural of rhombus? Turns out you get to take your pick. You can either call it rhombuses or rhombi. with two eyes at the end. What fun. All right, so now I'm going to turn the page and we're going to talk about quadrilaterals that are not parallelograms. Okay, so just to recap here, we have the quadrilaterals. Oh, come on. This can't be dead already. These are relatively new. Quadrilaterals. And we've already talked about one offshoot, which was parallelograms. Which then broke off into rectangles, rhombus, and then the two come together to make the square. Okay, so that's what we just talked about, all of that. Now we're going to branch off of rectangles, of quadrilaterals in two different ways. So another type of quadrilateral that is not a parallelogram. It has its complete own branch. The next one is going to be the trapezoid. So the trapezoid, I'm sure you are familiar with what those look like. You are still going to have four sides, right? That's why it still counts as a quadrilateral, because it's still a four-sided figure. But what makes a trapezoid is that you have one and only one pair of parallel sides. You can't have two, because if you have two pairs of parallel sides, now it's a parallelogram. So if you only have one pair of opposite sides that's parallel, it counts as a trapezoid. Okay? So it is a quadrilateral with only one pair of parallel sides. Okay, so could look something like this, where you have, in this case, top and bottom are parallel to each other like that. Okay, so that's what your trapezoids look like. Don't always think of the parallel sides. It doesn't have to be the top and the bottom. It could even look something like this. This could be a trapezoid. As long as you have one and only one pair of opposite sides that's parallel. Okay, now there is a subset of the trapezoid. There is? Yes, I'll tell you about it. Let's switch to purple. There is a special type of trapezoid where, I wonder if you can guess what the name of it is. It's a blank trapezoid. I'll give you the definition and you tell me. The word that goes in this blank is a vocab word that we have talked about before. So the blank trapezoid is a trapezoid where the non-parallel sides which are called legs, by the way, legs, are congruent. So it looks like this. So you have one pair of sides that's parallel, that makes it a trapezoid. But what's special about this type is that these other sides that are not parallel, they're equal to each other. So they're the same measure. So take a wild guess what type of trapezoid this is called. Oh, Olivia, you have the right word. It's the same as if we were talking about a triangle. If you had a triangle and you saw this, you'd call it a blank triangle. It's the same thing here. What do you call that triangle with two congruent sides? Same thing as you call the trapezoid. So hopefully you've got it in your brain. It is the isosceles trapezoid. Isosceles trapezoid. So if you have a trapezoid and it just so happens that those two other sides are equal in length, we call it an isosceles trapezoid. Okay, and then there is only one offshoot of quadrilaterals left to talk about. That's it. There's only one left. So let me go back up there. Let's go to blue. Blue should show up well. So I'm going to kind of scroll back up a little bit. So again, we are shooting off quadrilaterals on its own. We've got the last kind of thing. And it's called a kite. And it's exactly what you're thinking. Just like the kite that you would fly outside. Well, I mean, some kites can get very intricate. But you're a very basic kite. So if a kid were going to draw a kite, exactly what it would look like. All right. So let's draw the picture first, I guess. Usually looks something like that. So that's a terrible, hold on, I'll do this side better. There we go, that's pretty good. So what's so special about a kite? The kite is not just some random four-sided figure. It has to have two pairs of sides that are equal to each other, but they have to be neighboring sides. So these two sides are going to be the same, and then these two sides are going to be the same. And that's what is required to have a kite. All right, so let's put that in words. So it is still a type of quadrilateral because I still have four sides. So quadrilateral with two. And when you have them right in a row, one after another, we call them consecutive. Right? So like 3, 4, 5 are consecutive numbers. So consecutive would be one right after another. So two consecutive. Let's see if I can fit consecutive in there. Oh, I can. Two consecutive. Two pairs of consecutive sides congruent. And that is what makes a kite a kite. Quadrilateral with two pairs of consecutive sides congruent. And it really does look like a kite that you would draw and fly. Okay, so that's pretty much the entire quadrilateral family. There's no offshoots of the kite. It either is one or it isn't one. So you can have a four-sided figure, and it could be so many different things. So, in fact, let's try it. I'm wondering if I could use my my things here. Give me a second, and I'll put some together, and then maybe I'll have you tell me what you think they are. My brain will reach. Okay, so let's just take a look at a visual of some of these different things. So here I have put 4. Remember that if it's the same color, it's the same length. So here I just have 4 random sides. They're all different lengths. So this is just a quadrilateral. That's the most descriptive name I could give this thing. It's a 4-sided figure. That's the best I can do. You can kind of play around with it a little bit and change its shape a little bit, but that's still just a quadrilateral, right? It's not anything else. That's the best I can do. So if I wanted to make a parallelogram out of this, well, parallelograms have to have 2 pairs of parallel sides. Okay, so if I wanted to create that, what I would have to do is, let's see, if I wanted to, let me try this. Let's try and make the pink and the yellow parallel to each other. So that looks pretty close. The pink and the yellow are parallel. And now I want the green to be, there's no way that this is going to work out, right? I'd never be able to make those. So I'm going to have to make some changes. So why don't I go ahead and I'll replace the pink. I'll try. We are going to learn some rules of parallelograms. And I don't know, do we do that tomorrow? Yeah, tomorrow we're going to learn all about parallelograms. And it turns out that the only way for me to actually be able to create a parallelogram is if I actually have both pairs of opposite sides not only parallel, but they're going to have to be equal to each other. So now this shape here is a parallelogram. Check that out. And look, these are so cool because I can just change them like this. This is still a parallelogram, right? I still have 2 pairs of opposite sides that are parallel. So no matter how I kind of like play around with this, each of these shapes is still a parallelogram. How cool, right? Now, if I wanted to make this particular parallelogram into a rectangle, I'd have to stop it where those are perfect right angles. Okay, so that looks about good. Now I have a rectangle. All right, if I wanted to make this thing a rhombus, the only way to make a rhombus is to have all 4 sides the same length. So let me replace the yellows with 2 more greens. Okay, so now I have all 4 sides that are the same. And so if I want to make a rhombus shape, right, it could look like any of these things. It could be a very, very narrow diamond, or it could stretch out, stretch out, stretch out, stretch out. Any of these would count as a rhombus because it has exactly what it needs. The only definition for a rhombus is that it's a 4-sided figure with 4 congruent sides. So if all my 4 sides are the same, any shape that I can create with these is going to be a rhombus. Okay, so all of these count as rhombus, including this one where it just so happens to have 4 right angles. Do I have a more specific name for this thing? Yes, the square. So a square is just a rhombus that happens to have 4 right angles. You could also think of it the other way, that a square is just a rectangle that happens to have all 4 sides the same. How neat. Okay, so there's the parallelogram shapes. Now the other offshoots that we just talked about, we had the, what did we do first? Trapezoid. So let's get 2 pairs of sides that are parallel to each other. So let's take these 2. I've got the green and the yellow, and let's make them parallel to each other. So then I'm going to connect one side. Let's do that. And then I'll do, let's see, I might have to play around with the, I wonder if I could do this. I wonder if this would reach. Oh yeah, yeah, pretty close. There we go. So as long as that green and yellow are still parallel to each other, that would count as a trapezoid because I only have 1 pair of opposite sides that's parallel. Okay? If the two sides that were not parallel just so happen to be the same length, so if I replace that dark blue one with another pink, now I have created, there it is, my isosceles trapezoid. One pair of parallel sides, and then the other sides are equal in length. And then I have a question in the chat. Does that mean a rhombus can be a square if a square can be a rhombus? Yes. A rhombus can be a square, but it doesn't have to be. So there's a difference. The square is always a rhombus because a square always has all four sides the same. A rhombus doesn't have to have four right angles, but it can. I hope that makes sense. Okay, so here is my isosceles trapezoid. And then the last shape that we talked about was the kite. So for the kite, I need two pairs of sides that are the same. So let's take two pinks, and I'll take two greens. So that's all I need to make a kite, is having, let me, oh, for goodness sake. Let me snap these in here. It's not wanting to cooperate today. There we go. So this shape is now a kite. Two sides the same, and then another two sides that are the same. So cool. And that's really it for the kite. I mean, they can sort of change a little bit in shape. They can also kind of duck in on themselves like that. That's a, does anybody know the term for that? If you have a shape that caves in on itself, that's a hint. There's a word for this. You learn this word in science class when you were talking about the eye. Do you remember learning about the parts of the eye? It starts with a C. Maybe you didn't learn it. I don't know. Convex and concave are the ones that I'm talking about. This is concave. So any shape is a concave shape if it caves in on itself. So this shape that does not cave in is called convex. Do you remember learning those? Yeah. So you probably, I can remember it, seeing it in like a textbook. They would have like, so here's like concave because it caves in. And then you have convex shapes like this. But this is like, there's stuff in your eye that's shaped like that. I don't remember what. Cornea? I don't know. Anyway, so that's a side note. But so there's your kite. Oh, I have, oh, the eye socket? I don't, maybe. I thought it was like more inner parts of the eye, like the cones and the rods and the, do you guys still learn about that? I remember learning it, so, But anyway, so there is your kite. Other shapes can kind of, you could just have random quadrilaterals too, right? They don't have to have any sort of special thingies going on. So let me just show you. Here is just some, let me make this one for you. Here's just a random quadrilateral, right? Nothing special about it. This one, yeah, I can kind of, well, I didn't really pick good sides. Let's do, let me change this one to another pink maybe. Sorry, I'm trying to make a shape that'll go concave better. This one does. Okay, so there's just some quadrilateral, right? But then I can kind of push on the shapes and then there it goes concave if it caves in on itself. Kind of neat. All right, so that's it as far as naming it goes. So why don't I make a shape and you tell me what it is? And then there's one little fast fact that we need to learn about these and then we'll be done. So what is this shape? As best as you can tell. Give me just a second. What would be the most descriptive name that you can give me for this shape? So keep in mind that these thingies, if they're all the same colors, are the same length. So I don't have all four sides the same length here. Yes, parallelogram. I have two pairs of opposite sides that are parallel to each other. So that thing is a parallelogram. What is it now if those are right angles? What's the best name for that thing? Yes, now it's a rectangle. Okay, what would you call this thing? What's that? Be as specific as you can, because they're all quadrilaterals, right? But you want to be, yes, this is the isosceles trapezoid, right? You have one pair of opposite sides that's parallel, and then the two sides that are not parallel to each other are equal in length because they're both pink. Okay, what is this shape? Give me a second here. Okay, if those are going to be right angles in the corner, what is that thing? Yes, that is a square if those are right angles. And then if I just pinch it and make it that, what is it now? Now it's a rhombus. Well, it was always a rhombus, right? But if it's a rhombus that happens to have right angles, we're going to call it a square. But if I have four congruent sides and I don't have right angles, the best name for that thing is a rhombus. Okay, perfect. One more. What is this? I'm going to try and trick you. The most specific name you can give. Yes, that thing is a kite. You have two sides that are congruent, one right after another. Yep, perfect. Kites can start to look really funny, right? Especially when they duck in. Don't forget that they're still kites as long as you still have those requirements. Okay, so I mentioned that there's one last fun fact that we need to know, and you might already know this. I don't know. You tell me. Let's just take a random quadrilateral. So let me create one again. Here we go. So here is just some rando quadrilateral. Do you happen to know, obviously it has four angles, right? What do you get if you add up all four angles? Take a guess. I've got one guess so far. Anybody have another guess besides? Well, I want to know if I take so if I whipped out my protractor and I actually measured these four angles, 1, 2, 3, 4, and I added them all together, what do you think it would add up to? So if you recall in a triangle, right, the angles always added up to 180. Remember that? So if I took any triangle, didn't matter what it looked like, right? If I add up those three angles, it's always going to get me to 180. Always, always, always. So now I have a four-sided figure. So my question to you is, if I have four sides, what are they going to add up to? Three-sided figures added up to 180. What do you suppose a four-sided figure is going to add up to? Yes, 360. So basically two triangles, which makes sense because check this out. You can take any quadrilateral, it doesn't even matter. And if you just pick one vertex, doesn't matter which vertex you start at, who cares? You pick whichever one you want. You can turn that quadrilateral into two triangles. Look at that. So that one's 180 and that one's 180. So together it's going to make 360. Miss Ava, you can't do that with any quadrilateral. Oh, yes, you can. Yes, you can, even if it's a special one. Let me see. Let me go back to a parallelogram. Hang on. Here's a parallelogram. Watch, I'll just make my life easy and I'll line this one up. To make it a little longer. There we go. So there is a parallelogram, and you can always divide it into two triangles. So yeah, 180 and 180 is going to add to 360. So the big deal, the big takeaway from this, so somewhere in your notes, put a big old star. This is so important. The sum of the four angles in any quadrilateral, so it doesn't matter if it's a parallelogram, a kite, trapezoid, who cares? The sum of the four angles in any quadrilateral is 360 degrees. Always, always, always. Just like the sum in any triangle is 180, the sum in any quadrilateral is 360. So super big star, very important. And what an interesting bit of information. So what I would like to do now is I'm going to hop on over to, well, first, anybody have any questions right now? No? Okay. So I'm going to hop over to your homework and I'm going to do a couple of them. So give me a second. I think this one's on CUDA, so I got to make it live. Give me just a sec to do that. And so let's stop the share. I will. CUDA works. Post assignment. Now I got to remember passwords. Jeez. Let's try that. Nope. Okay, got it. This is B block, and we're going to do for the 29th post. Okay, so let me just hop into this and we'll just do a couple real quick. So the first section of this is going to be super easy. I'm going to give you a shape and it's going to have some markings on it, maybe. So based on the markings, since this side, this shape has all four sides marked congruent, the most specific name for this thing would be a what? Most specific. Yeah, this one's a rhombus. Now, is it a quadrilateral also? Yeah, it is because it has four sides, but we want the most specific name, right? Like my most specific name is Erica Savia, right? You're not just going to, human works too. I am a human, but I want the most specific name, just like this thing. So this shape is lots of other things too. It's a polygon, it's a quadrilateral, but its most specific name is rhombus. So you have a bunch of these like that. Should be pretty straightforward. This thing, if you have 4 right angles and 4 congruent sides, of course this thing has to be a square, right? Is it a rectangle? Yeah, it is, but there's a more specific name for this, right? So anyway, so you've got a bunch of these. Notice that if it's going to have parallel sides like this, they're going to be marked. So you know that this has one pair of parallel sides and not the other. So that's got to be a trapezoid. So now it's up to you to figure out if it's isosceles or not. I'm not going to do all of them for you. So here you'll see nothing's marked. So if you were thinking kite, well, kite would have to have it marked. Like I'd have to know that the 2 sides in a row are equal to each other. And there's nothing here that marks, that shows me that. So I don't know that this thing is a kite. So the best thing I could say in this case is just quadrilateral, right? I don't know that it's a trapezoid. I don't see that any of these sides are parallel. And maybe it might be a kite, but if it's not marked, I don't know that it is. All right, so that is marked. So that one you should be able to name easily. All right, anyway, so fast forward, you got a bunch of these, and then, eventually you're going to land on these. Let me actually do, hold on. Let me go back. I want to do this. Let's do this one first, okay? So I have some 4-sided figure. We just said that they all have to add to be 360. So what am I going to do? I'm going to grab my calculator. I'm going to add together what I already have. I have 80, 80, and 85. So all together, that's 245. So I'm just going to take 245 away from 360. And it turns out that that last angle has got to be 115. All right. Now, don't fall into, I'm worried that some of you are going to fall into a trap. I don't want you to. So just be mindful that your 3 angles that are going to be given, and then you got to find the 4th one. But the key is that they always add up to be 360. So now this particular one, if I just add 86, 94, and 86, 266, take that away from 360, it just so happens to be 94. Well, that's interesting because I already had a 94. I also noticed that these two happen to be the same. So there are some patterns that may come out with certain shapes. The problem is, without any markings, I don't know that that's going to happen. Okay, so what I'm nervous is that some of you are just going to assume, oh, it's just got to be the same across. That's not the case. Because if I go back to this one, right, my answer here was 115, and it was not the same as 80. So you just got to be careful. Don't just think that you can shortcut these. There are things that we will eventually learn when I know what shapes they are. But all I know is that they have 4 sides. This, I mean, that one, you know. Anyway, so does anybody have any questions on what the homework is? And that's it, I think. I don't think there's any, yeah, that's it. So you go up to 18, and then you're done. Any questions right now?